Hi folks, today we're going to take a look at the development of the quadratic formula. Now what the quadratic formula does for us is it solves quadratic equations. Now in particular, we know that we can take any quadratic equation and write it in this form. So even if you did have some terms on the right hand side of the equation, you can always just bring them over to the left hand side and write it in this form, having 0 on the right hand side. So when we think back at how we solved quadratic equations in the past, our first and easiest method was to factor the left-hand side to write it as the product of two binomials, and that made it very easy to solve. Problem being that most quadratic expressions are not factorable. So our next possible way of doing this was to complete the square. And once we've completed the square, we were actually able to solve for x directly by solving using opposite operations. So that's what we're actually going to use to try to come up with a formula. Is we're going to take the most general quadratic equation that we can write and perform that process of completing the square and solving for x, and hopefully come up with a formula that will allow us to circumvent all those steps in the future. So this is a bit of a long process, so if you need to stop the video every once in a while to check that the algebra does make sense, please do so. So the first step in completing the square would be to factor out the a. Regardless of what it is, we know we need to factor it out, again, only from the first two terms. So I'm going to factor out the a here. So here I'm left with x squared, and I know that in order to factor a number out, I have to divide it here. So I'm going to be left with b over a times x. Again, we don't care about the c. We'll deal with that at the very end. Okay. Next step is we need to set up what's in the bracket in order to create our perfect square. So the way we do that is we know that that middle term must be written as 2 times something times x. Okay, and we think, well, what would have to be in this bracket? And I realize, well, I'm going to need a b over 2a. And let's just check, because if I multiply 2 times b over 2a, the 2's cancel out. I end up with b over a, exactly what I have. So I haven't actually changed anything yet. I've just rewritten this in the form that I need. Now, in order to get my perfect square, I know I also need to add the square of whatever's in the bracket. So I need to add b over 2a squared. Problem here, as we know, is I've now added something new to the expression. So if I add something new to the expression, the way to take care of that is to subtract it also. Okay, so basically it's like adding 0, so I haven't really changed the expression. Okay, and then of course we've got the plus c equals 0. So now the first three terms here are the form we need to create our perfect square. I'll use square brackets here to be a little neater. So we know that these three terms are going to factor to x plus b over 2a squared. Okay, and then we're left with that other term, and let's actually square it here. So we'll square the numerator, b squared, over squaring the denominator, 4a squared. Okay, and again, plus c equals 0. And now we'll distribute out the a to both the perfect square and to the other term in the binomial here. Okay, so let's do that. Multiply a times the perfect square, x plus b over 2a, all squared, minus. Now when we multiply this, we notice that we have an a in the numerator and an a in the denominator. So let's actually cancel those out. So we're left with, we still have the b squared in the numerator, okay, but one of the a's in the denominator has reduced with this a that we've multiplied. So we're actually just left with b squared over 4a plus c equals 0. So we've now completed the square. We can move on to solving for x using opposite operations. But before doing that, I'd actually just like to call your attention to something. That if we've now completed the square, think of this as being, instead of a quadratic equation, think of this expression as being a quadratic function. And we know that when we complete the square, there's certain elements of this that give us important information. Okay, let's recall what the vertex form of a quadratic function looks like. And we know that that value inside the bracket actually represents the x value of the vertex. And the number that's left over here represents the y value of the vertex. Now, if I look at this expression, that's a bit of a complicated expression to memorize as the y value of the vertex. But this one here is a pretty easy expression. Now here, since we have x minus h in the bracket, what would the h value be? In this particular scenario, we see that h would have to be negative b over 2a. So what we've inadvertently found is a formula for the x value of the vertex, or for the axis of symmetry. So x equals negative b over 2a actually gives us the axis of symmetry. And of course, if we did want to find the y value of the vertex, we could just stick it back into the equation here in order to get the y value. So in looking for a solution to this equation, we actually found a rather nice formula. So essentially, we're making completing the square a bit of an obsolete procedure, at least for the algebra that we have to perform. Another thing I'd like you to notice is that if, again, you think of this as a quadratic function, so y equals ax squared plus bx plus c, you realize that the axis of symmetry, or the x value of the vertex, does not depend on the c value. It depends only on b and a. So next time you're solving a max-min problem, see if you can use this formula for the x value of the vertex. Okay, so that was a nice little discovery here, but we need to get to the issue at hand, which is to find a solution for this equation. Okay, so now let's start solving using opposite operations. So, got to follow the reverse order of BEDMAS. So this multiplication and this square we'll take care of later. So bring these to the other side, and that negative b squared over 4a becomes positive b squared over 4a, and then that will become minus c. Now while we're at it, we might as well try to simplify this here a little. So I'm not going to touch this side yet. Okay. This is where we have to remember how we add and subtract fractions, because essentially we've got a fraction here. This can be thought of as c over 1, and the way we subtract fractions is to work with a common denominator. So here our common denominator, well, it's going to have to be 4a. So let's remember how we add and subtract fractions. In this first fraction here, it already has 4a in the denominator, so we won't have to do anything to the numerator. So it just remains b squared. Okay. The second fraction has only a 1 in the denominator, so we'd have to multiply this by 4a to get the same denominator, but if we multiply the denominator by 4a, we're also going to have to multiply the numerator by 4a, so we have minus 4ac. Okay. Let's keep going. The next thing we'll have to do is divide the a to the other side. So x plus b over 2a, all squared. Okay. Now, here the a is in the numerator. If I bring it to the other side and divide it, it goes into the denominator. And lo and behold, what do we get in that denominator? Instead of 4a, we have a 4a squared. Okay. So let's go to the next step here. We have to get rid of this exponent too, so we're going to take the square root of both sides. And of course, I hope as I say that, everybody remembers that when I take a square root, I have to consider both the positive and negative answer. Okay, so here we have b squared minus 4ac all over 4a squared. Okay, now I actually think we can simplify this a little bit, because I notice that the denominator is not a perfect square, but the numerator is. So what I'm going to do here is the numerator, well, like I said, is not necessarily a perfect square, so I'm going to leave it under the square root, b squared minus 4ac, but I can take the square root of the denominator. And the square root of 4a squared, well, what two values multiplied to 4a squared? That would just be 2a. So I can remove that from the square root altogether. And then finally we get to our last step. We can bring this b over 2a to the other side, and of course it's an addition, so bring it to the other side. It'll become a negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. And in fact, I noticed that, I'll just show you that there. I noticed that I have two fractions with a common denominator. Okay, and how do we add and subtract two fractions with a common denominator? We keep the denominator the same, and we just add and subtract the numerators. So this can be simplified to negative b plus or minus square root b squared minus 4ac all over 2a. And this is one of the most famous formulas in mathematics. Okay, this is something you need to memorize. You'll be expected to know in all your future math courses that anytime you need to solve an equation of this form, in other words, any quadratic equation, because they can always be written in this form, you can sidestep all the procedure of completing the square. You can sidestep having to then solve for x directly and use this formula. All you have to determine is what the a, b, and c values are. So what we'll do here is we'll do an example. Okay, to show this, let's go to the next page. Okay, and let's take a look at an example as to how we can solve this. Okay, so in fact, I'm actually going to take an example that can be solved by factoring so we can check our answer, so we can convince ourselves that everything we did was fine. Okay, so I'm going to take something like x squared minus 5x plus 4 equals 0. So on the side, we'll solve that by factoring. We realize, oh, this factors to x minus 4 times x minus 1 equals 0. So that means either x minus 4 equals 0 or x minus 1 equals 0. So x is either equal to 4 or x is equal to 1. Now, this you'll notice when we finish using the quadratic formula, this is still shorter. So what I would suggest to you is that if you ever end up with a quadratic equation where the quadratic expression is simple, you should still give factoring a try, because if it is factorable, this is certainly much quicker. But as soon as the numbers get a little complicated, and certainly if you're working with fractions and decimals, you probably want to go straight to the quadratic formula. So, like I said, let's assume we didn't notice that it was factorable, or maybe it wasn't factorable at all. Let's apply the quadratic formula. So when you're first starting this, I would start by identifying what the a, b, and c values are. So we see the coefficient of x squared is 1, the coefficient of x is negative 5, that's our b, and then the constant coefficient is 4. And now all we have to do, now normally I wouldn't actually write out the quadratic formula, but the first few times you definitely should, because you need this memorized. This needs to be something that you don't even have to think about when you're writing it. Okay, so let's see what happens. Well, we have negative b, so we have the negative of negative 5, so that becomes positive 5, plus or minus. Okay, here we have b squared, so negative 5 all squared, that's 25. So you do see I skip some steps. I don't bother writing out negative 5 squared. If you feel you need to do that, you should definitely do it. Okay, minus 4 times a, which is 1, times c, which is 4, okay, all over 2 times a, which in this case here is 1. So let's start simplifying. 5 plus or minus, and here we have 25 minus 16, that's just 9, okay, over 2, and this happens to be a perfect square. Okay, if it's not, you would either leave it in the square root to get an exact answer, or if it was an application type question, you would estimate it with your calculator, keep, usually a couple of decimal places. So here we have 5 plus 3 over 2, or 5 minus 3 over 2, and so that's 8 over 2, which is 4, and this is 2 over 2, which is 1. Exactly the answers we got before. Okay. Now, the last thing I want to say here is, and let's rewrite what we have, that if you have any quadratic equation written in the form where one side is always equal to 0, the solutions to this equation, or solution, depending, is automatically given by this formula. Now I want you to think about the fact that quadratic equations, unlike linear equations, sometimes have two answers. Sometimes they have one answer, and in fact sometimes they have no answers at all. Okay, and we've gone through why that's the case. So given that we have this formula that should work for any quadratic equation, let's think about how we could tell whether this would have two solutions, one solution, or no solutions. And it all comes down to this square root, because we realize that if b squared minus 4ac is a negative number, well, we can't take square roots of negative numbers, certainly at this point. So right off the bat, we know there must be no solutions. Okay? If b squared minus 4ac is greater than 0, that means there's a positive number. We can take a square root of positive number. It means you're adding the number, then subtracting the number. So we would be getting two different answers. So that would guarantee two solutions. Okay? What would it take for us to have only one solution? Well, that's when we realize, oh, wait a minute. What if this thing inside the square root is equal to 0? Square root of 0 is just 0. So that I'm adding 0 or subtracting 0 is of no consequence. I would end up with just one answer. So b squared minus 4ac equal to 0 means that I have only one solution. Okay? So keep that in mind, that if all they want to know is whether the equation has 1, 0, or no solutions, 1, 0, or 2 solutions, the only thing you have to check is b squared minus 4ac. And depending on whether it's positive, negative, or 0, that'll tell you how many solutions there are. Okay? Again, I will say these two things once again, that in order to use the quadratic formula, your equation has to have 0 on one side of it, and this is a formula you have to memorize. Okay? So go and practice and go memorize that formula.